In this tutorial, we're going to take a look at how Unity serves as a scene graph. I have a blank Unity project here with your standard windows. We're going to use the primitives offered in Unity to create a simple robot structure. Essentially just a graphical representation of a robot. So I'm going to select game object, 3D object, and a cube. That places a cube in my scene at 0, 0, 0. This will serve as the torso of the robot. Let's rename that torso, and I'm going to scale the torso so that it better approximates the dimensions that I want for my robot. So I'm going to make it about 1/2 meter wide, 1 meter tall. For the torso, it's going to be a large robot, and let's do 1/4 meter for its depth. Now I'm going to duplicate this torso to create the head of the robot, and I will make the head a cube. And we need to move it in its correct position, approximately. Let's go ahead and create an upper arm. So this will serve as the right upper arm. Let's see, so because it's the upper arm, I'm going to make it only about 1/2 as tall. And I'm not going to make it as wide as the torso, so I'll shorten that. And now we just need to move it approximately in the correct location. I'm going to duplicate that to create the left upper arm. Let's duplicate the right upper arm to create the right lower arm. I just realized I did not move the left upper arm. Let's move that into the correct location. Let's also move the right lower arm in the correct location. And let's duplicate the left upper arm to create the lower arm and move that into the correct location. And let's give the robot some legs. So a right leg. Height is fine. I'm just going to cut down on the width and move it approximately where it should go. And then we will duplicate that to create the left leg. And we'll simply move that into place. Okay, so now we have a very rough representation of a robot. Now, the problem with our representation of the robot is currently, if I attempt to move the robot forward, or I attempt to rotate the robot, you'll notice that only the torso moves, and none of the body parts move relative to the torso. So, in order to fix this, one thing is to create an empty game object. We'll call this robot, and we'll put all of the geometry underneath it. And now if we move robot, it will essentially, all the body parts will move the way that we expect them to. But this really hasn't fixed our problem because, for example, if I want to rotate the robot's arm, notice only the upper arm rotates and the lower right arm does not rotate. The reason for this is because all of the geometry is currently on the same level of the scene graph. So we have to create a proper hierarchy first for this. So if you think about the way that the human body is normally structured, essentially the head, the upper arms, and the legs are connected to the torso. So they'll go underneath the torso. The right lower arm is connected to the upper arm, so it goes underneath it. And the left lower arm goes under the left upper arm, so it connects to it. So this partially solves our problem. So for example, if I now rotate my right upper arm, the right lower arm also moves, but you see this skewing effect here, right? So not only is the geometry visually skewing, but it also no longer matches the collider representations, which are also getting manipulated, and this is completely incorrect. Now the reason for this is due to the fact that we have non-uniform scale factors within our hierarchy. In particular, there's a few. So first, our right upper arm has a non-uniform scale factor, so it's not the same value across these scales. And our torso has a non-uniform scale factor. So how do we fix this without having to modify the scale values on our objects? The way that we do this is by using empty game objects with uniform scale factors to act as the connections within the scene graph, and we will use the geometry that we currently have to represent essentially the leaves of the scene graph. So they will all be at the bottom of the scene graph, but they'll be under the current corresponding joint. So we're going to create a joint for each body part. So the torso already has a joint. That's essentially the robot. We need to create one for the head. We'll duplicate that. Create one for the right upper arm. Duplicate that. Create one for the left upper arm joint. Now we need one for the right lower arm. One for the left lower arm. One for the right leg. And finally one for the left leg. Okay. So first, before we utilize these joints, we need to make sure that they're correctly in the correct location relative to the hierarchy. Right now, they're all at 0, 0, 0, so they're not going to really do much for us. In order to position them correctly where the geometry currently is, I need to actually break the hierarchy that we had just created. So I'm essentially going to drag all of this out. So we'll move the head out. We'll move the right arm out. And essentially I'm flattening the hierarchy back down to a single level with everything on the outside. Now what this allows me to do, again, the torso is going to stay more or less where it is. So I can just simply stick the torso underneath the robot, which is fine. The head is located up here, so I'm going to right click on its transform, which represents its positional, rotational, and scale information. I'm going to copy that component and I'm going to paste it onto the head transform, or the head joint. Now the scale factor here would be fine, but just for sake of sanity, I'm going to make it 1, 1, 1. That just keeps everything nice and clean. Let's do the right upper arm next. So I'll copy its transform, paste it onto its joint. You'll notice here that we do have a non-uniform scale joint, so we need to make it uniform. Again, 1, 1, 1 is the best standard. Let's do this for the left upper arm. Copy its transform, paste it into the left upper arm joint. Again, make sure the scale factor is uniform. Then we need to do the same thing for the right lower arm. Paste that into the right lower arm joint. We will repeat this for the left lower arm. Again, make sure that you have that uniform scale factor. 1, 1, 1 is preferable. Do it for the right leg. Again, you need that uniform scale factor. And then finally, we do it for the left leg. And make it uniform. Okay, so now if we look through, all of our joints are in approximately the correct location. So I'm pretty happy with this. And now what we need to do is we need to rebuild that hierarchy that we had just built, but we build the hierarchy with the joints instead of the geometry. So the head, the upper arms, and the 2 legs are connected to our torso joint, which is the robot. So let's make sure I don't deselect anything. So we'll put it underneath the robot. The right lower arm joint is connected to the right upper arm joint, and the left lower arm joint is connected to the left upper arm joint. Now, what about our geometry? So our geometry goes under each respective joint. So the left leg will go under the left leg joint. right leg under its joint, left upper arm under it, left lower arm under its joint. Now what's interesting to note here is you have the left upper arm joint. Under the left upper arm joint is the left lower arm joint, and on the same level of it is also the left upper arm geometric representation. All right, so let's go ahead and make sure that the upper arms are correct for the right arm, the lower arm joint, and let's make sure we have the head correctly connected. So now if we take a look at this, for example, if I want to rotate the robot's right arm, when I rotate it, we no longer have that skewing effect. The colliders stay within place the way that they're supposed to. And I can also rotate the right lower arm joint to make representations the way that you would expect in terms of animations. Now the reason that these aren't rotating correctly is because for each one of these joints, its pivot is actually in the center of the cube. That's just how Unity treats its cubes. Normally with most geometries like this, you would actually have the pivot point at a slightly different location. If we wanted to fix this, for example, I could by simply taking the right lower arm, that's the geometric representation. Let's actually drag it out and just stick it out by itself. And then let's take its lower arm joint, which is currently centered on it. And let's just slightly move that joint up so that it matches where we would expect it to go. So it's a little closer to the elbow location of the robot. Now, if we bring our right lower arm geometry back underneath the lower arm joint, and we do this again, essentially if we rotate the upper arm joint, the lower arm rotates with it, and when we rotate the lower arm joint, you get a bending at the elbow the way that you would expect. So this tutorial has demonstrated how Unity works as a scene graph and how your hierarchies are very important in terms of the way that the objects are manipulated and how they rotate relative to one another. And in particular, it has also demonstrated how important it is to make sure that you have a uniform scale factor, which means that your X, Y, and Z are equivalent. And in general, it's best if they all say 1. 1 is just a nice standard way to quickly determine that they do have a uniform scale factor. All right, thank you. I hope you enjoyed this